The storm is almost over, the snow has also stopped falling, millions are digging out, power is coming back on, and life is returning to normal. But something nobody's talking about is sitting right there in plain sight. 2 feet of frozen water, and next week it starts moving. What if the worst part of this winter storm isn't what just happened, but what's about to happen? Stay with me for the next several minutes because we're going to explore one critical question that could affect your property, your safety, and your community. Where does all that water go when 2 feet of snow suddenly melts on frozen ground? And why are government agencies quietly issuing flood warnings right now, while everyone else is celebrating the end of the storm? The lights are back on in most places, roads are being cleared. The National Guard is packing up. Everyone's breathing that sigh of relief that comes when a major disaster passes. You survived the blizzard, you made it through the blackouts, and now you're ready to put this whole ordeal behind you. That feeling is completely natural. We all want to believe the danger has passed when the immediate threat disappears. But here's what's happening that most people aren't seeing yet. Right now, across thousands of miles of the heartland, there's an extraordinary amount of snow sitting on the ground. In some areas, it's the heaviest snowpack in decades. That snow isn't just frozen precipitation anymore, it's stored water. Every inch of snow that fell during Winter Storm Fern contains water. Not a little bit of moisture, but actual liquid volume that's temporarily locked in ice crystals. Think about that for a moment. When you look outside at those piles of snow lining your driveway, stacked against your foundation, covering your yard, what you're actually seeing is water. Frozen, yes, but still water, and every bit of it is going to return to liquid form. The question isn't whether it will melt. Snow always melts eventually. The question is when, how fast, and where that water will go. Those 3 factors determine whether you get a gradual, manageable thaw or something requiring serious attention and preparation. And right now, all 3 factors are lining up in a way that has weather experts and emergency management officials concerned. Not panicked, not sensationalizing, just genuinely concerned based on conditions they're seeing and patterns they've seen before. Let me paint the picture of what's actually on the ground right now. From the Dakotas down through Kansas, across Missouri into Illinois and beyond, communities are buried under snowfall that measured not in inches but in feet. Some locations saw accumulations that broke records standing for generations. That's not exaggeration. That's documented snowfall data. The sheer volume of precipitation that fell during this storm was remarkable. But volume is only part of the story. What makes this situation different, what makes it potentially dangerous, is what happened before the snow arrived. Before Winter Storm Fern dumped all that snow, the region experienced a prolonged period of brutally cold weather. Arctic air settled over the heartland and stayed there for days. Temperatures didn't just dip below freezing, they plummeted. The kind of cold that makes your face hurt when you step outside. The kind of cold that freezes pipes, kills car batteries, and turns any exposed skin dangerous in minutes. That cold wave did something else. Something that doesn't make headlines but matters tremendously now. It froze the ground solid. Under normal winter conditions, the ground might freeze at the surface, but below that frozen crust, soil retains some ability to absorb moisture. Not this time. This cold was so intense and lasted so long that frost penetrated deep into the earth. The soil didn't just get cold, it became essentially impermeable, like concrete. Think of it like a frozen sponge. When a sponge freezes solid, it can't absorb anything. Water hits its surface and runs off. That's exactly what's going to happen when all this snow melts on frozen ground. The earth cannot drink it in. It has nowhere to go but sideways. Now here's where the timeline becomes critical. Right now, today, temperatures are still well below freezing across most of the affected region. That snow isn't going anywhere yet. It's sitting there, stable, frozen, not causing immediate problems beyond the sheer inconvenience of dealing with it. But weather forecasts are showing a significant pattern change coming, not someday far in the future, early to mid-February. Weather forecasts show a pattern shift coming that could raise temperatures substantially, not just above freezing, but potentially into ranges that trigger rapid snowmelt. When meteorologists talk about rapid snowmelt, they're describing a specific phenomenon where snow doesn't gradually diminish over weeks, but releases its water content over days, sometimes even hours. That's the scenario that transforms a manageable situation into a significant flooding situation, and that's the scenario the National Weather Service is monitoring as temperatures are forecast to rise in the coming weeks. You might be wondering why you haven't heard more about this. Why isn't this the top story on every news channel? Why aren't officials making major announcements? There are a few reasons. First, forecast certainty improves as events get closer. What looks likely today becomes definite tomorrow. Weather agencies tend to issue specific warnings as timing becomes clearer to avoid unnecessary alarm based on possibilities that might not materialize. Second, flood awareness simply doesn't generate the same immediate attention as a blizzard warning or tornado alert. Flooding often develops more slowly than other weather disasters, so the urgency doesn't feel as dramatic, even when the ultimate impact can be just as severe or worse. But make no mistake, the warnings are there, they're being issued. The National Weather Service released their spring flood outlook, and it contains language that should catch attention. They're forecasting above normal to major flooding potential across the very regions currently buried in snow. They're specifically citing snowpack levels and soil saturation as key risk factors. This isn't speculation based on worst-case models. This is assessment based on actual current conditions combined with historical precedent for what happens when those conditions meet warmer temperatures. Let me give you the 3 specific dangers we're going to explore in depth. First, there's the ice jam threat. Rivers are frozen right now. That ice is thick and solid from weeks of extreme cold. When temperatures rise and water from melting snow starts flowing into these rivers, that ice breaks apart. Massive chunks, some the size of vehicles, begin floating downstream. When they encounter obstacles like bridge pilings, narrow passages, or river bends, they pile up. They create instant dams made of ice. Water backs up behind these ice jams, and flooding happens within minutes or hours, not days. It's sudden, significant, and difficult to predict exactly where it will occur. Second, there's the rapid snowmelt flooding itself. Even without ice jams, when you have this much snow releasing its water content onto ground that cannot absorb it, water has to go somewhere. It flows into low-lying areas. It overwhelms storm drainage systems that might still be frozen or clogged. It seeks out every crack and seam in foundations. It pours into basements. It causes significant street flooding. In rural areas, it floods fields and roads. In urban areas, it creates flash flooding scenarios that can strand vehicles and create hazardous conditions. Third, and this is something not getting enough attention, there's the infrastructure vulnerability factor. The storm that just passed caused extensive damage. Power lines down, roads weakened by freeze-thaw cycles, storm drains blocked or damaged, sump pumps that couldn't operate during power outages. All of that storm damage has created weaknesses in the systems that normally help communities manage water. When snowmelt flooding hits areas with compromised infrastructure, the impacts multiply. A drainage system that would normally handle heavy runoff fails because key components are frozen, broken, or overwhelmed. These aren't 3 separate, unrelated problems. They're interconnected threats that can compound each other. An ice jam creates localized flooding. That flooding hits an area where storm drains are frozen, so water can't drain properly. The water finds a basement with a non-functioning sump pump. What might have been manageable can result in property damage. Scale that across thousands of square miles, and you begin to understand why authorities are concerned. I want to be absolutely clear about something before we go deeper. This isn't about creating fear. This is about creating awareness so you have time to prepare. Knowledge is power, especially when it comes to natural disasters. The difference between being caught off guard and being ready often comes down to information and time. Right now, you have both. You have information about what's developing, and you have time before it develops. That combination gives you the ability to take sensible precautions to protect yourself and your property. So if you're still with me, if you want to understand exactly what's happening, why it's happening, and what you can do about it, I'm going to walk you through this step by step. We're going to look at the science behind frozen ground and snowmelt. We're going to examine each of those 3 major threats in detail so you understand not just what could happen, but why it happens and where it's most likely to occur. We're going to review what official sources are actually saying in their flood outlooks, and most importantly, we're going to end with practical preparation steps you can take right now before temperatures begin to rise. Before we dive in, do me a favor, hit that like button so this information reaches more people who need to see it. Subscribe to this channel if you want to stay updated on important weather and safety information that affects your community. And drop a comment telling me where you're watching from. Are you in one of the areas that just got buried in snow? Have you already noticed water pooling in places it shouldn't be? Your experience matters, and sharing it helps others understand what to watch for. Let's get into this. the story of what's about to unfold doesn't start with the forecast warm-up in early to mid-February. It starts with understanding exactly what Winter Storm Fern left behind, and why this particular combination of conditions is so concerning to people who study floods for a living. Winter Storm Fern will be remembered as one of the most impactful winter weather events in recent memory for the sheer scope of disruption it caused. Millions lost power, thousands of flights were cancelled, major highways became impassable, communities were isolated for days. The human and economic costs are still being tallied. But for our purposes right now, we need to focus not on what the storm did during its rampage, but on what it left behind when the winds finally stopped. What remains is snow. An extraordinary amount of snow spread across an enormous geographic area. This isn't a localized heavy snowfall where one city gets buried while areas just a few miles away see flurries. This is regional-scale snowpack covering multiple states, with accumulations that range from impressive to historic. Some locations recorded snowfall totals that exceeded 2 feet. Others saw accumulations that broke records standing since measurements began. Even areas that didn't set records still received enough snow to create substantial snowpack that will persist until temperatures rise significantly. Snow accumulation by itself isn't automatically dangerous. Mountains receive massive snowfall every winter, and that snow sits there for months without causing disasters. Alpine snowpack is actually beneficial, serving as natural water storage that feeds rivers and reservoirs through the dry summer months. So what makes this situation different? Why is snow sitting on the ground across Kansas or Missouri more concerning than snow piled in the Rockies? The difference comes down to 3 factors: where it is, what's underneath it, and what's coming. Let's start with where it is. This snow isn't sitting on mountain slopes in wilderness areas. It's sitting on farmland, in residential neighborhoods, covering streets and parking lots, piled against buildings, and most significantly, sitting above river valleys and watersheds that drain into major river systems. The geography matters because geography determines where water goes when snow melts. Water always flows downhill. That's not profound wisdom, that's simple physics. But when you have massive amounts of water releasing over a short period, the details of local topography become critical. Which way does your street slope? Does water naturally flow toward your foundation or away from it? Where are the low spots in your neighborhood? In rural areas, which fields typically flood first during heavy rain? All of those normal drainage patterns will be working overtime when snowmelt begins. Now let's talk about what's underneath all that snow. Under normal winter conditions, ground might freeze at the surface but retain permeability below. Soil can still absorb some moisture. Root systems create channels for water infiltration. Even frozen soil can accept some water as temperatures fluctuate and surface layers thaw during sunny afternoons. But these aren't normal conditions. The Arctic blast that preceded the snow froze ground to unusual depths. We're not talking about a thin frozen crust. We're talking about frost penetration that has rendered soil effectively waterproof. Here's a simple way to understand what frozen ground means for water absorption. Imagine trying to pour water onto a block of ice. The water doesn't soak in, it can't. The ice is impermeable. The water sits on the surface or runs off to find a path of least resistance. That's what's going to happen when snowmelt begins. All that water hitting frozen ground will behave exactly like water poured onto pavement. It has to go somewhere, and that somewhere is wherever gravity takes it. Under normal spring conditions, when snow melts gradually over weeks, soil is thawing at the same time. As the snow releases water, the ground beneath is becoming more permeable, more able to absorb. It's a gradual process that allows for natural absorption and groundwater recharge. The water doesn't all flow into streams and rivers at once because much of it soaks into the earth. That natural absorption acts like a sponge, moderating the amount of runoff that reaches waterways. But when ground is frozen solid and stays that way while snow melts, that natural sponge doesn't work. Every drop of meltwater becomes runoff. Let's talk about the volume we're dealing with. Snow contains water at roughly a 10-to-1 ratio under typical conditions. 10 inches of snow equals about 1 inch of liquid water. That ratio varies based on snow density. Light, fluffy snow might be 15 or 20 to 1. Heavy, wet snow might be closer to 6 or 8 to 1. But as a general rule, 10 to 1 gives you a reasonable estimate. So when someone says an area received 2 feet of snow, what they're really saying is the area received approximately 2 to 3 inches of liquid precipitation that's currently locked in frozen form. 2 or 3 inches of rain falling over several hours would be considered a significant rainfall event in most places. It would cause localized flooding, especially in areas with poor drainage. Storm drains would be running full, low-lying areas would see standing water. Now imagine that same amount of water being released not over hours but over days, and not just in one location but simultaneously across an entire region covering thousands of square miles. Then factor in that it's not just 2 or 3 inches in isolated spots. Some areas are sitting under snowpack that represents 4, 5, 6 inches of liquid equivalent or more. The mathematical reality is stunning when you scale it up. A single square mile covered in 2 feet of snow contains roughly 60 million gallons of frozen water. Multiply that across the affected region, and you're talking about water volumes that strain comprehension. It's not just a lot of water, it's an almost unimaginable amount of water that's going to return to liquid form and start moving within days. Now let's talk about what's coming, because timing is everything in determining whether snowmelt becomes dangerous. Right now, that snow is stable. Temperatures remain well below freezing. The snow sits there, inert, not melting, not creating problems beyond the logistical challenges of moving it around and dealing with its weight on structures. If temperatures stayed cold for another month, giving ground time to thaw gradually as daylight strengthens and seasonal warming begins, the situation would be manageable. Spring snowmelt would happen the way it usually does, slowly and steadily, allowing natural systems to handle the water. But that's not what's forecast. Weather models are showing a significant temperature surge coming early next week. The same polar vortex pattern that brought the Arctic cold is shifting. Warmer air is going to push northward, and temperatures across the region are forecast to rise substantially. Not just barely above freezing, but potentially climbing well into the 40s, or even 50s in some areas. That kind of warmth, especially if accompanied by sunshine, triggers rapid snowmelt. Rapid snowmelt is a specific term with a specific meaning in hydrology and flood forecasting. It refers to situations where snowpack releases a significant portion of its water content in a compressed time frame. Instead of snow gradually diminishing over a week or two, it can disappear in days. The water that was locked in that snow for days or weeks suddenly becomes liquid and mobile over a very short period. That compression of the melting timeline is what transforms a normal seasonal process into a flood threat. What makes rapid snowmelt even more dangerous is if precipitation accompanies the warmth. Rain falling on existing snowpack creates what meteorologists call a rain-on-snow event, and it's one of the worst-case scenarios for flooding. The rain adds its own water volume to the system, but it also accelerates snowmelt by transferring heat energy directly into the snowpack. Rain is warmer than snow, and when it percolates through snow layers, it melts snow from within while also adding liquid water. The combination can triple or quadruple runoff volumes compared to what warmth alone would produce. Current extended forecasts show the potential for precipitation, along with the warming trend. If that precipitation falls as rain rather than snow, which is likely given the forecast temperatures, then we're looking at precisely that rain-on-snow scenario. Even if precipitation doesn't materialize, the warmth alone is sufficient to initiate significant snowmelt. But the addition of rain would accelerate everything and amplify all the impacts we're about to discuss. This is why the National Weather Service issued their flood outlook when they did. They're not waiting for the snowmelt to begin before warning people. They're looking at current conditions, the snowpack that exists right now, the frozen ground situation, and forecast weather patterns, then making assessments based on those factors. Their outlook, which we'll examine in detail later, reflects serious concern about flooding potential across the region, not speculation, assessment based on measurable current conditions and historical precedent. So that's the legacy Winter Storm Fern left behind. Not just disruption and damage from the storm itself, but an enormous volume of frozen water sitting on ground that cannot absorb it, waiting for temperatures that will release it all at once into drainage systems and watersheds that may not be able to handle the sudden surge. That's the setup. Now we need to understand why the ground's frozen state makes everything so much worse. And that requires looking at the specific mechanism that turns soil into something resembling concrete. To understand why this snowmelt situation is potentially dangerous rather than just inconvenient, you need to understand what happens to soil when it freezes deeply and stays frozen. This isn't complicated science. You don't need a degree in hydrology to grasp the basic mechanism, but understanding it makes everything else make sense, so let's walk through it carefully. Soil is made up of particles: sand, clay, silt, organic matter. Between those particles are spaces, tiny gaps and channels that allow air and water to move through. Those spaces are what give soil its ability to absorb water. When rain falls on normal ground, water infiltrates into those spaces, percolating downward through soil layers until it either reaches the water table or is taken up by plant roots. This infiltration capacity is what prevents every rainstorm from becoming a flood. The ground acts like a massive sponge, absorbing tremendous quantities of water that would otherwise run off into streams and rivers. But when water in soil freezes, everything changes. Water expands when it freezes. Those tiny spaces between soil particles, which normally allow water movement, become filled with ice. The ice locks the soil structure into a rigid matrix. Think of it like the difference between loose gravel and concrete. Loose gravel allows water to flow between the stones. Concrete, where those stones are locked together with hardened cement, is essentially waterproof. Frozen soil behaves much more like concrete than like loose. Permeable earth. The depth of frost penetration matters enormously. If only the top inch or two of soil freezes, warmth and snowmelt can thaw it relatively quickly. But when frost penetrates 6 inches, 12 inches, even deeper, it creates a barrier that persists long after surface snow begins to melt. The frost line, the depth to which freezing temperatures penetrate into the earth, depends on how cold it gets and how long it stays cold. The longer and colder the freeze, the deeper the frost. The Arctic outbreak that preceded Winter Storm Fern was extraordinary in both intensity and duration. This wasn't a quick cold snap that lasted a day or two. This was sustained, extreme cold that lasted for days on end. Nighttime temperatures dropped to levels rarely seen even in midwinter. Daytime highs stayed below zero in many locations. That kind of prolonged, intense cold drove frost deep into the ground, deeper than is typical for winter conditions in these regions. Now, here's the problem. Snow is actually an insulator. Once thick snow covers the ground, it insulates the soil beneath from both warming and further freezing. That sounds like it might be helpful, but it actually locks in the current frozen condition. The ground can't freeze deeper because the snow blanket protects it from colder air, but it also can't thaw because the snow prevents warming sunshine and milder air from reaching the soil. So the frost that penetrated deep during the Arctic blast is now locked in place under feet of insulating snow. When temperatures rise next week and snow begins to melt, the water from that melting snow will encounter frozen ground. The surface might thaw a bit as warmth penetrates, but several inches down the soil remains frozen solid. That frozen layer acts as a barrier, preventing water infiltration. It's as if the landscape has been covered with a waterproof sheet. Water from melting snow cannot soak into the earth. It must flow across the surface, following the path of gravity and topography, until it reaches a stream, river, storm drain, or simply pools in low-lying areas. Think about what happens in your own yard during a summer thunderstorm when rain falls heavily. If the soil is dry and can absorb water quickly, even intense rain might soak in without creating much runoff. But if the soil is already saturated from previous rain, additional water has nowhere to go. It sits on the surface, forming puddles, flowing toward low spots. That's what's going to happen when snow melts on frozen ground, except it's not just your yard. It's every yard, every field, every parking lot, every street, all at the same time across a vast area. Normally, spring snowmelt happens gradually over weeks, as seasonal warmth returns. March, sunshine melts snow during the afternoon. Nighttime refreezing slows the process. Ground thaws progressively as temperatures moderate. By the time significant melting occurs, soil is receptive again, able to absorb meltwater. The system is designed by nature to handle spring snowmelt through a slow, steady process that allows natural absorption and prevents excessive runoff. But rapid snowmelt on frozen ground breaks that natural system. The snow releases its water faster than ground can thaw. You get a rush of water across an impermeable surface. It's not the way nature intended the spring transition to work, and when natural systems are pushed outside their normal parameters, problems emerge. The landscape can't handle the volume of water in the compressed time frame. Drainage systems become overwhelmed. Waterways experience sudden surges. Flooding results. Let me give you a comparison that makes this concrete. Imagine you have a large sponge. If you pour water onto that sponge slowly, it absorbs everything. The water disappears into the sponge. No overflow, no mess. Now imagine the same sponge but frozen solid. Pour water onto frozen sponge and what happens? The water runs off the surface. The sponge cannot absorb anything in its frozen state. It doesn't matter how slowly you pour the water. The frozen sponge has no absorption capacity. That's frozen ground and snowmelt. Just now scale that analogy up. Instead of one sponge, imagine thousands of square miles of frozen ground. Instead of a cup of water, imagine millions of gallons of meltwater being released simultaneously. The water has nowhere to go except into drainage networks that were designed to handle rain, not the equivalent of several inches of rain falling across an entire region within days. Where does that water go? It follows topography, it flows downhill. In rural areas, it fills ditches, floods fields, overtops rural roads, and rushes into streams and creeks that feed into larger rivers. In residential areas, it flows along streets towards storm drains. It seeks out any entry point into basements, foundation cracks, window wells. In urban areas, it overwhelms storm sewer systems, backs up into streets, creates localized flash flooding. The vulnerable locations are predictable if you know your local geography. Low-lying areas always flood first because that's where water naturally accumulates. If you've lived in your home for years, you probably know the spots in your neighborhood that puddle after heavy rain. Those spots will flood when snowmelt begins, only worse because there's more water over a longer period. Areas near streams and rivers face additional risks because those waterways will be receiving not just local runoff but upstream runoff from miles of melting snow. Foundation walls and basements become particularly vulnerable. Water flowing across frozen ground seeks any path to lower elevation. If your foundation has any cracks or seepage points, water will find them. If your basement typically stays dry because soil around your foundation absorbs rainwater before it penetrates, that protection disappears when ground is frozen. The water can't absorb into frozen soil, so it sits against your foundation, finding every weakness. Sump pumps, which many homeowners rely on to keep basements dry, face their own challenges. If your area lost power during the storm and your sump pump wasn't on a backup system, water may already be accumulating. If discharge lines from sump pumps are frozen or buried in snow, pumps may run but not effectively move water away from the foundation. If temperatures have kept sumps frozen, they may not function at all when you need them most. Storm drains face similar issues. Many storm drains are currently frozen, clogged with ice, or buried under piled snow from ploughing operations. Even if the drain openings are clear, the pipes beneath may be frozen solid. When meltwater begins flowing toward these drains, they won't have capacity to accept and channel water the way they normally would. Water backs up, floods streets, seeks alternative paths. In some cases, frozen storm drains can create flash flooding in urban areas, even from relatively modest amounts of meltwater, because the drainage infrastructure simply isn't functional. Road conditions add another concern. Roads weakened by freeze-thaw cycles during the winter become susceptible to washout when heavy water flows across or under them. Culverts that channel water under roadways can become clogged or damaged. When water cannot pass through a culvert properly, it either floods the road surface or erodes around the culvert structure, undermining the roadbed. Rural roads especially face these hazards, and a washed-out road in a rural area can isolate communities and hamper emergency response. All of these vulnerabilities trace back to the same root cause: frozen ground preventing water absorption. If the ground could drink in the meltwater the way it does during normal spring thaw, most of these problems would be manageable or wouldn't occur at all. But it can't. The frost barrier is real, it's extensive, and it's going to persist even as surface snow disappears. That's why this situation is fundamentally different from normal snowmelt, and that's why the concern level among those who monitor flood risks is elevated. The frozen ground problem sets the stage for everything else we're going to discuss. It's the underlying condition that makes the three specific dangers we need to examine much more serious than they would be otherwise. Understanding this foundation helps you understand why a warm-up next week isn't just welcome relief from winter cold, but potentially the trigger for significant flooding. With that foundation in place, let's look at the timeline and the specific temperature thresholds that will determine when and how fast this unfolds. Right now, today, the situation is stable. Snow sits on the ground, frozen and inert. The danger is potential, not actual. But that stability has an expiration date, and according to current forecasts, that expiration date arrives early next week. Understanding the temperature timeline is crucial because it tells you when to heighten awareness and when to take preparatory action. Temperature is the key variable that determines whether snow melts slowly or quickly. Snow doesn't simply melt the moment temperatures rise above freezing. The melting process depends on how much energy is available to transform ice into liquid water. That energy comes from air temperature, sunlight, and if present, warm rain. The combination and intensity of these factors determine the melt rate. When temperatures hover just above freezing, around 33 to 35 degrees, snowmelt happens but slowly. A few hours of weak sunshine might create some surface melting during the afternoon, but nighttime refreezing halts the process. This slow melt pattern is ideal for managing runoff because water is released gradually over days or weeks. Natural systems can accommodate the steady trickle of meltwater without overwhelming streams or drainage infrastructure. But when temperatures climb well above freezing, especially into the 40s or 50s, the energy available for melting increases dramatically. Warmer air temperatures mean the atmosphere itself is transferring heat energy into the snowpack continuously, not just during sunny afternoon hours. Nighttime temperatures staying above freezing mean melting continues around the clock. The snow doesn't get a chance to refreeze and stabilize, it just keeps melting, releasing water at rates that can reduce substantial snowpack in days rather than weeks. Current extended forecasts for the affected region show temperatures climbing significantly during early to mid-February. After days of bitter cold, where highs struggled to reach double digits and lows plunged well below zero, the pattern shifts dramatically. Forecast high temperatures for the middle of next week show widespread readings in the 40s across areas currently buried in snow. Some locations may even approach 50 degrees. That's not a gradual warming. That's a sharp temperature spike that will trigger rapid snowmelt. Timing matters because it gives you a window for preparation. Current forecasts show warming beginning in early February and intensifying mid-month, giving you time now to assess your property, check your drainage systems, move vulnerable items, and monitor official warnings. That window is valuable. But it's not unlimited. Waiting until snow is actively melting to start thinking about flood protection is waiting too long. The forecast warm-up shows consistent signals across weather models. Multiple forecast systems indicate warmer air moving into the region, though exact timing may vary by several days. While exact temperature values might vary by a few degrees between different model runs, the overall pattern is clear. Cold air retreats, warm air advances, snowmelt begins. The question isn't whether this will happen. The question is exactly how warm it gets, and whether precipitation accompanies the warmth. Precipitation is the wild card that could transform a significant melt into a more serious flood situation. Rain falling on snow, as mentioned earlier, accelerates melting while also adding its own water volume. Current long-range forecasts show some potential for precipitation during the warm-up period. Whether that precipitation materializes, and if so, whether it falls as rain or snow, will depend on the exact track and intensity of weather systems moving through next week. If precipitation stays minimal and warmth is the only factor, snowmelt will still happen but at a somewhat manageable pace. Snow will diminish over several days, water will flow into drainage systems steadily, rivers will rise but perhaps not exceed flood stage in most locations. It won't be ideal, but it might avoid the worst-case outcomes. However, if even moderate rain falls during the warm period, all bets are off. Rain-on-snow scenarios can produce flooding that rivals or exceeds what heavy thunderstorms produce, because the water volume is simply staggering. Think about it this way. A 2-inch rainstorm is a significant event. It causes localized flooding, fills streams, and creates hazardous driving conditions. Now imagine that 2-inch rainstorm, but instead of the water just coming from the rain itself, it's also melting 6 inches of snow cover at the same time. You're not dealing with 2 inches of water. You're dealing with 2 inches from rain plus another 3 inches from accelerated snowmelt. That's 5 inches of liquid water entering the system over a day or two. Very few drainage systems can handle that kind of volume without flooding. The National Weather Service watches these scenarios closely. Forecast meteorologists and hydrologists analyze temperature trends, precipitation potential, and snowpack data to determine flood risk. When they see conditions aligning toward likely flooding, they issue flood watches, then warnings as the event approaches. For this situation, some river forecast centers have already included above-normal flood risk in their spring outlooks. As next week approaches and forecasts become more certain, you can expect to see more specific watches and warnings issued for particular rivers and communities. Your job right now is not to predict exactly what will happen. That's what meteorologists do. Your job is to stay informed about what forecasters are predicting and to take sensible precautions based on that information. Checking weather forecasts daily becomes important, not just looking at the temperature numbers, but reading the forecast discussions that explain what meteorologists expect and why. Many National Weather Service offices provide detailed forecast discussions on their websites that give much more context than television forecasts can provide in brief segments. The countdown is real. Right now, you have several days before the warmth arrives. That's your preparation window. By the time temperatures are in the 40s and snow is visibly melting, your opportunity to prepare is closing. Water will be moving. Conditions will be changing rapidly. Taking action, then, is reactive rather than proactive. Taking action now, while conditions are stable, means you're ahead of the situation rather than trying to catch up to it. What should you be doing during this countdown period? We'll cover specific preparedness steps in detail later, but the general answer is assess your vulnerabilities. Walk around your property and look at where snow is piled. Is it against your foundation? Clear it away from the house if possible. Where does water naturally flow on your property? Make sure those drainage paths are clear. Do you have a sump pump? Test it. Is it working? Is the discharge line clear? Do you have valuables in your basement? Consider moving them to higher levels. These aren't panic measures. They're prudent steps that reduce your risk. For those living near rivers and streams, the timeline matters even more. River flooding from snowmelt typically happens a day or two after melting begins, because it takes time for water to flow from higher elevations down into river valleys, and for those rivers to respond to the increased inflow. So even after temperatures rise and melting starts, you may have a brief additional window before river flooding materializes, but that window is short, and once rivers start rising, they can rise quickly, especially if ice jams form. Ice jams are perhaps the most unpredictable element of the entire scenario because they can cause flooding with very little warning. A river might be flowing normally, below flood stage, and then suddenly an ice jam forms upstream. Within an hour, water levels rise dramatically as flow is blocked and backs up. There's no gradual rise that gives extended warning time. It's sudden and localized, which makes it particularly dangerous. We'll examine ice jams in detail next, but they're worth mentioning here in the timeline discussion because they can disrupt the normal progression of flood development. The bottom line on timing is this: the clock is ticking, but it hasn't run out. The danger is coming, but it's not here yet. You have time, but not unlimited time. The forecast warm-up in early to mid-February is the trigger. What happens after that trigger is pulled depends on how warm it gets, whether rain falls, and how your local geography and drainage systems handle the surge of meltwater. Some areas will manage without serious problems, others will see significant flooding. Which category your community falls into depends partly on factors beyond anyone's control, but it also depends on how prepared individuals and communities are when the melting begins. As we move forward into examining the 3 specific dangers in detail, keep this timeline in mind. Everything we're about to discuss happens in the context of the forecast temperature rise in early to mid-February being the starting gun. Understanding when things will happen helps you understand when to take action and when to be most vigilant about monitoring conditions. Now let's look at the first and potentially most dramatic of the 3 major threats: ice jams and the instant flooding they can create. Rivers and streams across the affected region are frozen right now. Solid ice covers the water, sometimes several feet thick after weeks of extreme cold. That ice formed gradually as temperatures stayed below freezing day after day. Water froze, then more water froze on top of that, building up thick ice layers. In some rivers, ice extends from bank to bank. In others, ice shelves cling to the edges, while a channel of flowing water remains in the middle. But everywhere there's substantial ice that's been locked in place for weeks. That ice is about to become mobile. And when it does, it creates one of the most dangerous and unpredictable flooding scenarios that exists: ice jam flooding. An ice jam is exactly what it sounds like. It's a traffic jam, but instead of cars, it's massive chunks of ice piling up in a river. When river ice breaks up during warming periods, it doesn't simply melt in place. It fractures into pieces, ranging from small chunks to slabs the size of cars or even small houses. These pieces begin floating downstream with the current, just like any debris in flowing water. As long as the river channel is wide and straight, the ice flows along without incident. But rivers aren't straight. They bend, they narrow. They encounter obstacles like bridge pilings, islands, and shallows. When flowing ice meets these obstacles, it starts to pile up. Imagine logs floating down a river. If those logs encounter a narrow passage or a bridge, they can stack up, creating a temporary dam. Now replace those logs with ice chunks that can weigh tons each, and you have an ice jam. These ice dams can form in minutes. One moment, ice is flowing freely. The next, a key piece wedges against a bridge support. More ice piles up behind it, and within a short time, you have a solid mass of ice blocking the entire river channel. When an ice jam blocks a river, water can't flow past it. The river doesn't stop flowing. Water keeps coming from upstream, but it can't continue downstream because the ice dam blocks its path. So the water does the only thing it can. It backs up. River levels rise rapidly upstream of the jam. Water spreads out beyond the normal channel, flooding adjacent land. Flood levels can rise several feet within an hour, sometimes even faster. Property near the river that was perfectly safe suddenly finds itself underwater with almost no warning. This is what makes ice jam flooding so particularly dangerous. Most river flooding develops over hours or days. Water rises gradually. Forecasters can predict when rivers will reach flood stage and issue warnings with plenty of lead time. People have time to evacuate, move belongings, and prepare. Ice jam flooding doesn't provide that luxury. The jam forms quickly, flooding happens quickly, and by the time you realize there's a problem, water may already be surrounding buildings or covering roads. Ice jam flooding is also highly localized. While the jam exists, flooding occurs in a specific area upstream of the jam location. Areas downstream might actually see reduced water levels because flow is blocked. Then, if the jam releases suddenly, that backed up water rushes downstream in a surge, potentially causing downstream flooding. It's unpredictable, difficult to forecast, and can catch communities off guard even when they're watching for general flood risks. History provides sobering examples of ice jam flooding disasters. The 1996 Pacific Northwest floods were significantly worsened by ice jams that formed during a rapid melt event. Communities experienced severe, widespread flooding not just from snowmelt runoff, but from ice jam backups that sent water surging into areas that hadn't flooded in generations. Property damage was extensive. Lives were lost. That event is seared into the memory of emergency managers in affected regions, and it's part of why current conditions are causing concern. Another example occurred in 2011 across parts of the northern plains. After a winter of heavy snowfall, spring warm-up triggered widespread ice breakup on rivers. Multiple ice jams formed along the same river systems. Flooding occurred in waves as jams formed, released, then formed again downstream. Emergency responders spent weeks dealing with flooding incidents that kept popping up in different locations as ice moved through the river network. It was exhausting for response teams and terrifying for residents who never knew if their community would be next. The conditions we have right now mirror those historical events in concerning ways. Heavy snowpack, frozen rivers, frozen ground, and forecast rapid warm-up. Those are the ingredients that produced ice jam flooding in the past. The National Weather Service is aware of these parallels. That's why their outlooks reference ice jam potential specifically. This isn't hypothetical, it's a real threat based on real precedent. Certain locations are more vulnerable to ice jams than others. Bridge crossings are high-risk areas because bridge pilings narrow the channel and provide obstacles for ice to catch against. River bends, especially sharp bends, create natural pinch points where ice can pile up. Shallow areas or rapids where the river channel becomes constricted are also prone to jams. If you live near a river, knowing whether your location is upstream or downstream of these natural jam points helps you assess your personal risk. Islands and channel splits also create ice jam risks. When a river divides around an island, ice flowing down can pile up at the point where channels rejoin. Similarly, locations where tributaries join larger rivers are jam-prone because ice from multiple sources converges. Local historical knowledge is valuable here. Long-time residents often know that spot on the river where ice always jams based on experience from previous winters. That local knowledge is worth seeking out and taking seriously. The size of the ice chunks matters. Thin ice breaks into smaller pieces that can flow through obstacles more easily. Thick ice, like what currently exists after weeks of extreme cold, breaks into massive slabs that are much more likely to wedge and create jams. Think of the difference between trying to push small ice cubes through a funnel versus trying to push solid ice blocks. The blocks will jam the funnel immediately. That's what thick ice does in river channels. Predicting exactly when and where ice jams will form is very difficult, even for experienced forecasters. Forecasters can identify high-risk areas and time windows when breakup is likely to occur, but the exact location and timing of jam formation is too chaotic and dependent on too many microscale factors to predict accurately. A jam might form at a bridge, or it might form 2 miles upstream, or it might not form at all if ice breaks small enough to flow through. This uncertainty is frustrating, but it's the reality of ice jam phenomena. What can be predicted is when ice breakup will begin. As temperatures rise above freezing and stay there, especially when warming is rapid, River ice weakens and fractures. The ice along riverbanks melts first because it's in contact with warmer land and receives more direct sunlight. Once the ice detaches from shore, it becomes mobile. Then the entire ice sheet begins breaking apart as temperatures continue warming. This process typically begins 1 to 3 days after sustained above freezing temperatures arrive. When temperatures rise significantly into the 40s and 50s, ice breakup typically begins within 1 to 3 days of sustained above freezing conditions. That's the danger window. For residents near rivers, this means heightened vigilance is required during that time frame. Watch for signs of ice movement on the river. Listen for cracking sounds which indicate ice is breaking up. Monitor local emergency alerts because if authorities become aware of an ice jam forming, they'll issue warnings. Most importantly, have an evacuation plan ready if you're in a flood-prone area near a river. Know your route. Know where you'll go and be ready to leave quickly if warnings are issued. Minutes can matter with ice jam flooding. Responders have limited tools to deal with ice jams once they form. In some cases, icebreaker boats can be deployed to try to break up jams, but that's dangerous work and not always feasible depending on the size of the jam and river conditions. Sometimes controlled explosives are used to fracture ice jams, but that requires specialized expertise and equipment. Often, the only option is to wait for the jam to release naturally, which it eventually will as warming continues and ice melts. But while the jam exists, flooding occurs, and there's not much that can be done except manage the consequences. The unpredictability of ice jam flooding means you can't wait for official warnings to prepare. By the time a warning is issued for a specific ice jam, flooding may already be occurring. Your preparation needs to happen now before ice breakup begins. If you live near a river, assume the risk is real. Move valuables to higher floors, have important documents ready to grab, know your evacuation route, keep vehicles fueled and ready. These precautions take time to implement properly, and that time is now, not when ice is moving. Even if you're not directly on a river, ice jam flooding can affect you. When rivers flood, they close roads, evacuation routes get cut off, emergency services become stretched responding to multiple incidents. Power infrastructure near rivers can be damaged, causing outages. The ripple effects of ice jam flooding extend beyond the immediate flood zone. Being aware of the broader community risk helps you prepare for potential disruptions, even if your home isn't directly threatened. One often overlooked aspect of ice jam flooding is the damage that ice itself can cause beyond the water. When an ice jam releases and water surges downstream, it often carries ice chunks with it. These chunks, weighing tons, can damage structures, docks and bridges along the river channel. It's not just a flood, it's a flood carrying battering rams. The debris field left behind after ice jam flooding can be extensive, with huge ice blocks deposited far from the river channel. The bottom line with ice jams is this: they are perhaps the most dangerous and least predictable aspect of snowmelt flooding. You can't know exactly if or where they'll happen, but you can know that conditions right now favour their formation. Heavy snowpack, thick river ice, rapid forecast warming, and frozen ground creating increased runoff all point toward elevated ice jam risk. Historical precedent shows what can happen when these conditions come together. The smart approach is to treat the risk as real, prepare accordingly, and stay alert during the critical period next week when ice breakup is likely to occur. Ice jams are danger number one, but they're not the only threat. Snowmelt flooding can happen even without ice jams, and that's what we need to examine next. Even if ice jams don't form, rapid snowmelt alone creates substantial flood risk across the region. This is the more widespread, less dramatic, but potentially more impactful of the flood threats. While ice jams create sudden, localized disasters, snowmelt flooding affects broader areas and can persist for days as accumulated runoff moves through watersheds into rivers and ultimately downstream. This is the kind of flooding that inundates fields, closes roads, fills basements, and turns quiet streams into raging torrents. The mechanism is straightforward. When snow melts, the water it releases flows downhill following the path of least resistance. Under normal circumstances, much of that water soaks into the ground. What doesn't soak in flows into storm drains, culverts, and small streams, which channel it into progressively larger waterways. This system works reasonably well when snowmelt is gradual and ground is thawed, but when melt happens rapidly and ground is frozen, the system becomes overwhelmed. Picture every rooftop, every driveway, every street, every yard releasing water simultaneously over a period of days. That's the reality of rapid snowmelt. It's not concentrated in one place, it's happening everywhere at once. The cumulative effect is staggering. Small streams that you can normally step across become raging channels too dangerous to approach. Ditches designed to handle rainwater overflow their banks. Storm drains meant to handle street runoff become geysers as water backs up from overwhelmed systems. In rural areas, snowmelt flooding manifests as field flooding and road closures. Agricultural land becomes saturated and impassable. Rural roads, especially gravel or unpaved roads, turn to mud or become flooded. Low-lying areas that collect water become temporary lakes. Farmers can't access fields. Delivery trucks can't reach remote properties. Communities become isolated not by snow, but by the water that snow became. This disruption can last for days or even weeks, depending on how long it takes for water to drain or for rivers to recede enough to allow repairs. In residential areas, the threat focuses on property damage. Basements are particularly vulnerable. Water flowing across frozen ground seeks any entry point. Foundation cracks that normally never leak become seepage points. Window wells fill with water that then pushes through window seals. Basement flooding from snowmelt can happen even in homes that have never experienced water problems before, because the conditions are unusual. Frozen ground eliminates the natural protection that soil absorption normally provides around foundations. The insidious nature of snowmelt flooding is that it doesn't announce itself dramatically. There's no thunderstorm, no visible weather event. The sun might even be shining. But hour by hour, water is moving, accumulating, finding low spots. A homeowner might notice a small amount of water in a basement corner and think it's minor, not realizing that water is going to keep coming for days, potentially turning that small seepage into inches of standing water. By the time the problem seems serious, it's already serious. Storm drainage infrastructure in cities and towns faces extraordinary stress during rapid snowmelt events. Storm sewers are designed based on rainfall intensity and duration that might be expected in that location. Engineers calculate system capacity based on historical weather data. But snowmelt runoff can exceed those design parameters, especially when you have an exceptional snowpack melting rapidly over compressed timeframes. The storm drains simply can't handle the volume of water trying to enter the system. When storm drains can't keep up, water backs up into streets. This creates urban flooding even when rivers remain within their banks. It's flash flooding without the flash, just a steady rise of water in low-lying streets and intersections. Vehicles become stranded, roads close. The same infrastructure people rely on for mobility becomes impassable. This type of flooding is especially dangerous for the elderly or those with mobility limitations because it can develop while conditions seem relatively normal, then suddenly create hazardous conditions. The rain as no scenario deserves special attention because it dramatically amplifies everything. Rain by itself adds water volume to the system, but when rain falls on snow, it does more than just add volume. The rain is warmer than the snow, so as it percolates through the snowpack, it transfers heat. That heat melts snow from within. The result is that you're getting water not only from the rain itself, but also from accelerated snowmelt triggered by the rain. The two sources combine to create runoff volumes that can be triple what either the rain or the melt alone would produce. Meteorologists can model rain-on-now events fairly well, which is why forecasters watch precipitation forecasts so closely during melt periods. If next week brings not only warmth but also significant rainfall, the flood outlook changes from concerning to potentially severe. Even moderate rain, amounts that would normally be unremarkable, become significant flood producers when falling on deep snowpack. It's the combination that's dangerous, not necessarily extreme amounts of either factor individually. Historical examples show how destructive rain-on-now flooding can be. The Midwest floods of 1993, while primarily a river flooding disaster that lasted months, began with rain-on-now events that triggered initial river rises. The Pacific Northwest floods of 1996, mentioned earlier in the ice jam section, were also heavily influenced by rain falling on mountain snowpack, creating runoff that fed the rivers where ice jams then formed. More recently, various winter flooding events across the northern tier states have followed the same pattern. Snow accumulation, frozen ground, then warm rain triggering rapid melt and flooding. The duration of snowmelt flooding is another factor that distinguishes it from other flood types. A thunderstorm might drop several inches of rain in hours, causing flash flooding, but then it's over. The water drains away fairly quickly because the precipitation event was short. Snowmelt flooding doesn't work that way. The precipitation event is continuous. As long as temperatures stay warm and snow remains, water keeps flowing. The flooding isn't a brief surge, it's a sustained elevated flow that persists for days. Rivers rise slowly but stay elevated longer. Water accumulates in areas where drainage is poor and just sits there because more water keeps arriving. For rivers, this sustained runoff means prolonged flood conditions. A river might reach minor flood stage and then hover there for a week, as snowmelt continues feeding water into the system. Even though the flooding isn't catastrophic at minor stage, it still affects riverside communities, closes recreation areas, damages infrastructure, and prevents normal activities. The economic impact of prolonged moderate flooding can sometimes exceed short-duration major flooding, simply because the disruption lasts so much longer. Predicting exactly how high rivers will rise from snowmelt is complex. It depends on how fast the snow melts, how much rain falls, if any, how much water is already in the ground from previous events, and how efficient river channels are at conveying water downstream. Hydrologists build computer models that simulate all these factors to produce river forecasts. These forecasts appear in National Weather Service river statements and show predicted crest levels and timing for specific river gauges. As next week's weather develops, these forecasts will become more precise, giving communities specific information about expected flood levels. For individuals trying to assess their risk, the key is knowing your local geography. Do you live in a floodplain? Check FEMA flood maps, which are available online for most communities. Has your area flooded before during heavy rain or past snowmelt events? Talk to neighbours who have lived there longer. Where does water naturally flow in your neighbourhood? You can often tell just by walking around and observing the landscape. These factors help you gauge whether rapid snowmelt will affect your property directly or whether you're in a safer location that will avoid the worst impacts. Even if your home isn't at risk, snowmelt flooding affects your community. Roads close, creating detours and delays. Schools might close if bus routes become impassable. Businesses near flooded areas shut down temporarily. Essential services can be disrupted. Understanding that community-wide impacts are possible helps you prepare not just for personal property protection, but for broader disruptions to normal routines. The timing curve of snowmelt flooding typically lags behind the warm-up by a day or two. Temperatures rise, snow begins melting, water flows across the landscape and into streams. Then rivers respond to that increased inflow, so even after temperatures climb into the 40s and melting accelerates, the peak flood risk on rivers might not arrive until several days later. This lag time is actually helpful because it provides warning. Once melting is underway, you can track river forecasts and see predictions for when rivers will crest. That gives you time to take final protective actions before flooding becomes severe. The challenge is not reacting too late. Once rivers are already at flood stage, your options become limited. Sandbagging becomes difficult because materials and labour are in short supply as everyone tries to protect property simultaneously. Evacuations become complicated because floodwaters may have already cut off routes. Moving belongings out of basements is hard when water is already coming in. The effective preparation window is before flooding begins, which means acting this week while conditions are still stable, not next week when water is moving. Snowmelt flooding is inevitable in some form. The snow has to melt eventually, and when it does, water has to go somewhere. The question is not whether there will be any flooding, but how extensive it becomes. That depends partly on weather factors beyond anyone's control, but it also depends on how communities and individuals prepare. Good preparation doesn't prevent flooding, but it absolutely reduces damage and keeps people safer. That leads us to the third major danger, which is often overlooked but compounds everything else: the vulnerability of infrastructure that's already been stressed by the winter storm. The winter storm that buried the region in snow didn't just leave behind snowpack, it left behind damage, some visible and some hidden, to the infrastructure people rely on to manage water and maintain safety. When flooding arrives on top of that storm damage, the impacts multiply. Systems that would normally help communities cope with high water are compromised, frozen, or non-functional. This creates a compound disaster scenario where one problem amplifies another. Start with the most basic piece of home infrastructure for flood protection: the sump pump. Millions of homes in the affected region have basements, and millions of those basements stay dry thanks to sump pumps that automatically activate when water accumulates in a sump pit. These pumps are designed to handle seasonal groundwater and the occasional heavy rain. They're not designed to handle days of sustained snowmelt inflow, but more critically, many of them aren't functioning properly right now. During the storm, millions lost power for extended periods. While power was out, sump pumps didn't run. If water was seeping into basements during that time, and in many cases it was as the storm brought some rain and sleet along with snow, that water accumulated without being pumped out. Some basements flooded during the storm itself. Others have standing water that homeowners haven't noticed yet. When snowmelt begins and additional water starts seeping in, pumps that are already dealing with existing water become overwhelmed. Even for pumps that are working, discharge lines present problems. Sump pumps move water from inside the basement to outside the home through a discharge pipe. If that pipe exits into an area that's now buried under feet of snow, the water has nowhere to go. If the pipe itself is frozen, water can't flow through it. The pump runs but doesn't effectively remove water because the discharge is blocked. Homeowners might hear their pump running and assume everything is fine, not realizing the water isn't actually leaving the property. Fixing these issues now, before snowmelt begins, is essential but often overlooked. Testing your sump pump takes minutes. Pour water into the sump pit until the float activates the pump. Does it run? Does water flow out the discharge pipe? If snow is piled where the discharge exits, clear it away so water can flow freely. If you suspect the discharge line is frozen, you may need to thaw it or arrange alternative discharge. These aren't fun tasks in winter weather, but they're far easier to handle now than when your basement is flooding. Storm drains across affected communities face similar problems. Many are frozen solid from weeks of extreme cold. Others are buried under snow piles from ploughing operations. Still others are clogged with ice, debris, or both. Storm drains that aren't functioning can't accept runoff from streets. Water has to go somewhere else, which usually means it floods streets or flows overland into areas where it shouldn't be going. Urban flooding risk increases dramatically when storm drains aren't operational. Municipalities are aware of this problem, but clearing and ensuring functionality of every storm drain in a city is a massive undertaking, especially when crews are still dealing with snow removal and storm damage repairs. Some drains will be cleared and functional before melt begins, others won't be. As an individual, you can help by clearing snow away from storm drains in your immediate area if you're physically able. That simple action can prevent localized street flooding in your neighborhood. Road infrastructure took a beating during the storm and the preceding cold period. Freeze-thaw cycles crack pavement, plows scrape surfaces and damage road edges. The weight of snow and ice stresses bridges and culverts. Now those already damaged roads have to handle the additional stress of heavy water flow. In some cases, they won't hold up. Roads can wash out when water flow undermines roadbeds or when culverts fail to channel water properly underneath pavement. Culverts are particularly vulnerable. These are the pipes or channels that allow water to flow under roads at low points or stream crossings. If a culvert becomes clogged with ice or debris, water can't pass through. The water then flows over the road, which can lead to rapid erosion and road failure. A washed-out road doesn't just create an inconvenience, it isolates communities, blocks emergency vehicles, and can take weeks to repair. Rural areas face the greatest culvert risks because rural roads have more culverts and less frequent maintenance. Bridges are another concern. Bridge structures experience stress during the storm, and some sustain damage that may not be immediately apparent. When rivers rise during snowmelt flooding, bridges face increased hydraulic pressure from higher, faster-flowing water. If ice is flowing in the river, bridges face potential impacts from ice chunks hitting pilings. A bridge weakened by storm damage becomes more vulnerable to failure under flood conditions. While catastrophic bridge failures are rare, partial failures or damage that requires bridge closures are realistic possibilities during flood events. Power infrastructure is still recovering in many areas. Crews have been working around the clock to restore service after widespread outages, but repairs are ongoing. Some areas still have damage that hasn't been addressed because crews are triaging based on priority. When flooding occurs, it creates additional threats to power systems. Substations in flood-prone areas can be inundated. Downed power lines that are partially repaired can fail again if flooding causes additional stress or movement. Power outages during flooding are particularly problematic because they disable sump pumps precisely when they're most needed. The compound effect of infrastructure vulnerability is that communities are less resilient to flooding than they would be under normal circumstances. A city's flood response plan assumes certain capabilities. Storm drains function, roads are passable, power is available, communication systems work. When storm damage has compromised those systems, response becomes more difficult and impacts become more severe. This is why emergency managers are particularly concerned about this situation. They're not just dealing with flood risk. They're dealing with flood risk in communities that are still recovering from major storm impacts. Water treatment and wastewater systems face their own vulnerabilities. Many treatment plants are located near rivers because that's where they discharge treated water. When rivers flood, treatment plants can be threatened. If a plant goes offline due to flooding, Communities lose sewer service, which creates public health risks. Even without plant flooding, overwhelmed storm sewers can lead to combined sewer overflows, where untreated sewage mixes with stormwater and discharges into waterways. This is an unfortunate reality of aging urban infrastructure under extreme stress. For individuals, the infrastructure vulnerability issue emphasizes the importance of self-reliance and preparation. You cannot assume systems will function normally. You cannot assume help will arrive quickly if you need it. Emergency services will be stretched responding to multiple simultaneous incidents across wide areas. If flooding affects your property, you may be on your own for hours or even days before assistance reaches you. That reality makes personal preparedness not just advisable, but essential. Understanding your home's specific vulnerabilities is the first step. Do you have a basement? Is your sump pump functional and properly discharged? Are there cracks in your foundation that could admit water? Is your property in a low-lying area? Do you have battery backup power for critical systems? These questions help you identify where you're vulnerable and what you can do to reduce risk. Beyond your home, understanding community vulnerabilities helps you anticipate broader disruptions. Know which roads in your area are prone to flooding. Identify alternative routes. Know where your community's emergency shelter locations are in case evacuation becomes necessary. Have a communication plan with family members in case power or cell service is disrupted. These preparations extend beyond just flood protection to general disaster readiness, which is valuable regardless of the specific threat. The infrastructure vulnerability danger is the least visible of the three major threats we've discussed, but in many ways it's the most insidious because it amplifies everything else. Ice jams are more dangerous when roads are impassable and emergency response is delayed. Snowmelt flooding is more damaging when sump pumps aren't working and storm drains are clogged. Every weakness in infrastructure becomes a multiplier on flood impacts. That's why this third danger, while perhaps less dramatic than ice jams or widespread flooding, deserves serious attention and mitigation effort. With all three dangers now laid out, the question becomes, is this all just theoretical concern, or are authorities actually worried about this scenario? Let's look at what official sources are saying, what warnings have been issued, and what historical precedent tells us about situations like this. Everything discussed so far might sound concerning, but you might reasonably wonder, are experts actually worried about this? Or is this just one possible scenario among many? That's a fair question, and it deserves a clear answer based on what official sources are actually saying and what data they're working with. The answer is unambiguous, authorities are concerned, warnings have been issued, and the flood outlook for the region is the most elevated it's been in years. The National Weather Service operates a network of river forecast centres across the country. These centres employ hydrologists who specialise in predicting river behaviour and flood potential. They analyse snowpack data, soil moisture conditions, frost depth, current river levels, and weather forecasts to produce flood outlooks that guide emergency management decisions. These aren't casual predictions. They're scientific assessments based on decades of data and sophisticated modelling. In late January, the North Central River Forecast Centre, which covers much of the area affected by Winter Storm Fern, released their spring flood outlook. This outlook, which is updated regularly as conditions change, paints a concerning picture. They're forecasting above normal flood potential across a broad swathe of the region, with some areas showing potential for major flooding. The specific language used in these outlooks is carefully chosen. Above normal doesn't mean a little bit of nuisance flooding. It means flooding that exceeds what communities typically experience in an average year. The drivers of this elevated flood risk, according to the official outlook, are exactly the factors we've been discussing. Above normal snowpack across the region, frozen ground limiting infiltration, the potential for rapid melt events if temperatures rise quickly. All of these elements are documented in the official outlook. This isn't speculation from unofficial sources. This is the government agency responsible for flood forecasting saying that conditions are concerning. River-specific forecasts provide even more granular information. For major rivers across the affected region, forecast centres produce predictions of expected crest levels and timing. These forecasts show many rivers are expected to reach minor, moderate, or even major flood stage during the spring melt period. While exact timing depends on weather that hasn't happened yet, the projections are based on current snowpack and typical melt scenarios. If warmth arrives early, as forecasts suggest it will next week, these flood predictions could materialise earlier than typical spring flood season. Flood stage categories help communities understand risk levels. Minor flood stage might mean water reaches low-lying areas but doesn't threaten most structures. Moderate flood stage typically means significant inundation of flood plains, road closures, and potential damage to structures in vulnerable areas. Major flood stage means widespread severe flooding with extensive property damage and potentially dangerous conditions. When forecasts show rivers potentially reaching moderate or major flood stage, that's a signal for serious concern and preparation. The historical context makes current conditions even more noteworthy. Snowpack measurements across the region are being compared to historical records, and several locations have snow water equivalent values that rank among the highest observed in recent decades. Some areas have snow water equivalent measurements that haven't been seen since major flood years in the past. When hydrologists see snowpack levels comparable to years that produce significant flooding, they pay attention because history provides guidance about what may come. The flood of 1996 in the Pacific Northwest serves as a historical benchmark for rapid melt flooding. That event occurred when heavy mountain snowpack, followed by warm temperatures and rain, produced severe flooding across multiple states. Lives were lost, property damage ran into billions of dollars, and entire communities were devastated. The conditions that preceded that event were remarkably similar to conditions that exist now in the Midwest and Great Plains: exceptional snowpack, frozen ground, then rapid warm-up. History doesn't repeat exactly, but it often rhymes, and the parallels are concerning. The Midwest floods of 1993 provide another historical reference, though that event was different in character and timing. The 1993 floods were primarily spring and summer floods, caused by relentless rainfall over months. But they began with spring snowmelt that set the stage for what followed. Rivers were already elevated from snowmelt when the heavy rains of summer arrived, and the combination produced one of the most devastating flood disasters in American history. The current situation doesn't match 1993 precisely, but it shares some elements, particularly the above-normal snowpack that initiates river rises. More recently, 2011 saw significant spring flooding across the northern plains and upper Midwest. That flooding was driven by heavy snowpack combined with rapid melt and spring rains. Rivers remained above flood stage for weeks. Communities were evacuated. Agricultural damage was extensive. Emergency managers who dealt with 2011 floods are part of teams assessing the current situation, and they're drawing on lessons learned from that experience to prepare for potential flooding this year. Geographic targeting in flood outlooks helps communities understand their specific risk. Not every location faces the same level of threat. Areas near major rivers have different risks than areas on higher ground. Floodplains are inherently more vulnerable than elevated terrain. The National Weather Service provides flood outlooks down to the county level in many cases, allowing residents to see whether their specific area is highlighted for above-normal risk. Checking these outlooks for your location is a valuable step in assessing your personal situation. Probability language in flood forecasts helps communicate uncertainty. Forecasters might say there's a 70% chance of a river reaching flood stage, or a 40% chance of major flooding. These probabilities reflect the inherent uncertainty in forecasting events that depend on weather that hasn't occurred yet. A 70% chance doesn't mean flooding is certain, but it does mean conditions strongly favour it happening. Understanding these probabilities helps you calibrate your response. Even a 50% chance of significant flooding warrants preparation, because those are coin flip odds on a potentially serious event. Ice jam potential is specifically mentioned in many river forecasts for the region. Forecasters note that thick ice on rivers, combined with forecast warm-up and increased runoff from snowmelt, create elevated ice jam risk. They can't predict where jams will form exactly, but they can identify rivers and river segments that have higher susceptibility based on historical jam locations and current ice conditions. These mentions in official forecasts validate that the ice jam concern is not theoretical, but recognized by experts as a real threat. Timing guidance in flood outlooks gives communities a sense of when to heighten vigilance. For the current situation, outlooks indicate that flood risk increases substantially in early February and continues through late winter into spring. The early February timing aligns with the forecast temperature rise we've discussed. As next week approaches, forecasts will become more specific, potentially identifying particular days when river crests are expected, or when ice breakup is likely to occur. Monitoring these updates becomes important as events unfold. The spring flood outlook is not a warning, it's an outlook, meaning it describes what conditions suggest about future flood potential over weeks or months. Actual flood watches and warnings are issued closer to events, typically days or hours before flooding is expected. As conditions develop next week, if models show specific flooding is likely, the National Weather Service will issue flood watches for areas expected to be affected. If flooding becomes imminent, watches are upgraded to warnings. Understanding this progression helps you know when to take action. Outlooks mean prepare and monitor. Watches mean heighten readiness. Warnings mean take action immediately. Local emergency management agencies use these federal outlooks to inform their own planning and public communication. County emergency managers, city public works departments, and local first responders are all tracking the situation. Many communities are pre-positioning resources like sandbags, high water rescue equipment, and emergency shelters in anticipation of potential needs. If you see local government announcements about flood preparations or public meetings about flood risk, that's a sign officials are taking the situation seriously, and you should too. The convergence of official outlooks, historical precedent, and current conditions creates a compelling case that flood risk is real and elevated. This isn't about generating alarm. It's about recognizing that people who spend their careers studying floods are concerned about the current setup. When the National Weather Service says flood potential is above normal, when river forecasts show multiple waterways potentially reaching flood stage, when local emergency management is preparing, those are signals that shouldn't be ignored. None of this means severe flooding is certain. Weather is inherently uncertain. The warm-up might be less intense than currently forecast. Precipitation might stay minimal. Snowmelt might occur gradually enough that impacts are manageable. Best-case scenarios are possible. But best-case scenarios are not guaranteed, and planning based solely on hoping for the best is unwise. Prudent planning acknowledges the range of possibilities and prepares for scenarios that are concerning even if they're not guaranteed. The official information available to you right now is extensive. National Weather Service websites provide detailed flood outlooks, river forecasts, and explanatory information. Local news outlets are covering the flood potential. Emergency management agencies are providing guidance. The information is out there. The question is whether people access it and take it seriously enough to act on it. Too often, warnings are issued but not heeded until events are already underway, and then preparation becomes difficult or impossible. This is your opportunity to be ahead of the situation. You now know what experts are forecasting. You know why they're concerned. You know what historical events show is possible. The question is what you do with that information. Do you dismiss it as unlikely to affect you personally? Do you acknowledge the risk but fail to prepare because it feels abstract? Or do you take concrete steps now while you have time to protect yourself and your property? The choice is yours, but the information is clear. Flood risk is real, it's elevated, and it's approaching quickly. With that foundation of understanding in place, let's move to the most important part of this entire discussion: what you can actually do about it. Understanding the risks is valuable, but understanding without action doesn't protect you. Knowledge becomes power only when it's translated into preparation and smart decision-making. The good news is that there are concrete steps you can take right now to reduce your risk and protect what matters most. These aren't complicated measures requiring special skills or significant expense. They're practical actions that any homeowner or renter can accomplish with modest effort. The key is doing them now, this week, while conditions are stable. Not waiting until next week when water is already moving. Start with monitoring official information sources. You need reliable, timely information about what's actually happening with weather and flood forecasts. The National Weather Service website for your region is the gold standard source. You can find river forecasts, flood watches and warnings, detailed forecast discussions, and real-time river gauge data. Bookmark the relevant pages. Check them daily. Sign up for email or text alerts if your local NWS office offers them. Local news outlets also provide coverage, but go directly to the source for the most accurate and up-to-date information. For your property, begin with a thorough assessment of vulnerabilities. Walk around your home with flood risk in mind. Where is snow piled up? If it's against your foundation, that snow will melt directly adjacent to your house, increasing the likelihood of water finding its way inside. Clear snow away from foundations if you're able to do so safely. Move it at least several feet away so meltwater flows away from rather than toward your home. This is hard work, especially when dealing with heavy, compacted snow, but it's one of the most effective flood prevention measures you can take. Examine your property's grading and drainage. Does the land slope away from your house, or does it slope toward the foundation? You can't change your lot's topography in a few days, but understanding the natural water flow helps you anticipate where problems might occur and where you need to focus mitigation efforts. If water naturally flows toward your home, consider creating temporary barriers or channels to redirect it. Even small berms made from snow or sandbags can alter water flow enough to protect critical areas. If you have a basement, that's your highest risk area for flood damage. Start by testing your sump pump. Pour water into the sump pit until the pump activates. Verify it runs and that water is actually being discharged outside. Follow the discharge line to where it exits and make sure the exit point is clear of snow and ice. If the discharge line is frozen, you need to address that now. Some people use heat tape to keep discharge lines from freezing. Others route lines to locations less likely to freeze. If you're unsure how to handle a frozen discharge line, calling a plumber now is better than dealing with a flooded basement later. Consider backup power for your sump pump if you don't already have it. Battery backup systems are available at hardware stores and can keep pumps running during power outages. Given that power infrastructure is still vulnerable after the recent storm, the possibility of additional outages during flooding is real. A battery backup isn't cheap, but it's far less expensive than repairing a flooded basement. If battery backup isn't feasible, at minimum know where your sump pit is and have a plan for manually removing water if power fails and the pump stops working. Move valuable items out of basements and away from potential flood areas. Important documents, family photos, electronics, anything that water would damage should be relocated to higher floors. This seems obvious, but is often overlooked until too late. People don't want to believe flooding will affect them personally, so they delay moving things until water is already seeping in. Then it's too late, and irreplaceable items are damaged or destroyed. Moving things now takes time and effort, but it's easy compared to the heartbreak of losing treasured possessions to flood water. Document your property's current condition with photos or video. Walk through your home and yard, documenting what things look like before any flooding occurs. This documentation becomes critical if you need to file insurance claims later. Insurance adjusters need to know what was damaged, and having before and after photos substantiates your claims. This takes less than an hour, but can make a huge difference in insurance settlements if damage occurs. Speaking of insurance, review your homeowner's policy right now. Does it cover flood damage? Most standard homeowners' policies specifically exclude flood damage. Flood insurance is separate, typically purchased through the National Flood Insurance Program. If you don't have flood insurance, you cannot buy it now and have it cover imminent flooding. Flood insurance policies have waiting periods before coverage begins, but knowing whether you're covered helps you understand your financial risk and make informed decisions about how much effort to invest in physical flood prevention. For those near rivers or in known flood-prone areas, evacuation planning is essential. Know your evacuation route, know where you would go if you had to leave home quickly, have emergency contact information readily available. Keep important documents together in a waterproof container that you can grab quickly. Have a go bag prepared with essentials, medications, changes of clothes, important papers, chargers, cash. If warnings are issued and officials recommend evacuation, you need to be able to leave within minutes, not hours spent trying to gather everything you might need. Keep your vehicle fueled. This seems minor but matters significantly during emergencies. If you need to evacuate or if flooding disrupts normal activities and you need to travel farther for supplies or services, having a full tank eliminates one worry. Gas stations can lose power during emergencies, making refueling difficult or impossible. Fill your tank now and keep it topped off through the risk period. Stock emergency supplies for potential disruptions. Even if your home doesn't flood, community-wide flooding can create problems. Roads close, stores may be unreachable. Sea, power could be interrupted. Have enough food, water, and essential supplies to be self-sufficient for at least several days. This isn't about doomsday prepping. It's about basic readiness for temporary disruption. Canned goods, bottled water, batteries, flashlights, battery-powered or hand-crank radio, first aid supplies, medications. The standard emergency kit that everyone should have anyway becomes especially important during flood situations. If you're physically able and conditions allow, consider helping neighbours who may be less able to prepare on their own. Elderly neighbours, those with mobility limitations, or people who lack the physical strength to move snow or prepare their properties would benefit from assistance. Community resilience comes from people helping each other. A few hours of your time helping a neighbour could prevent serious problems for someone who couldn't manage preparations alone. Stay aware of community resources and plans. Many communities offer sandbags for residents who need them for flood protection. Find out if your city or county is making sandbags available, where to get them, and how to use them effectively. Know where emergency shelters would be opened if evacuations occur. Understand what communication methods your local emergency management uses. Some communities have reverse 911 systems that call residents with emergency information. Others use social media, local radio, or sirens. Know how you'll receive emergency information in your area. For rural residents or those on private wells, flooding creates additional concerns. Floodwater can contaminate wells, making water unsafe to drink. If your area floods, assume your well is contaminated until you can have it tested. Have bottled water available for drinking. Avoid using well water for consumption until testing confirms it's safe. Floodwater carries sewage, chemicals, and other contaminants that can remain in wells even after floodwaters recede. Monitor river levels in real time if you live near waterways. The National Weather Service operates river gauges that provide current water levels updated throughout the day. Many NWS websites show these gauges on maps, with colour coding to indicate whether rivers are below flood stage, approaching flood stage, or in flood. Watching these gauges as melt begins lets you see whether rivers are rising as forecast and gives you early indication if conditions are worsening. This real-time data empowers you to make informed decisions about whether to implement additional protective measures or whether conditions are developing more benignly than feared. Understand that not every forecast threat materializes. Weather forecasting is not perfect. Conditions may develop less severely than worst-case scenarios suggest. Rivers might rise but not reach flood stage. Ice jams might not form. Snowmelt might occur gradually enough to be manageable. If that happens, if next week comes and goes without significant flooding, your preparation wasn't wasted. It was insurance. You took reasonable precautions against a real threat that, fortunately, didn't manifest severely. That's success, not overreaction. But don't let optimism prevent preparation. The entire point of preparing is to be ready for the scenario where things do go wrong. If you prepare and nothing happens, you've lost some time and effort but gained peace of mind. If you don't prepare and flooding occurs, you face potentially devastating consequences. The asymmetry is obvious. The cost of preparation is modest. The cost of being unprepared could be enormous. Throughout all of this, maintain perspective. Flooding is a natural event that communities in these regions have dealt with throughout history. People survive floods. Property can be repaired or replaced. The goal isn't to eliminate all risk, which is impossible. The goal is to reduce risk to manageable levels and to protect lives first, property second. If faced with a choice between personal safety and saving possessions, always choose safety. Nothing you own is worth risking your life to protect. Finally, recognize that the situation is dynamic. Forecasts will change as new data becomes available. What looks concerning today might look better tomorrow, or it might look worse. Stay flexible. Don't lock into one interpretation of what will happen. Keep monitoring information. Keep adjusting your plans based on the best available forecasts. The decisions you make today about preparation might need to be expanded or modified based on how next week's weather actually develops. The empowerment in all of this comes from recognizing that you have agency. You can't control the weather. You can't prevent snowmelt or stop rivers from rising, but you can control how prepared you are, how much risk you've mitigated around your property, and how ready you are to respond if conditions worsen. That control, that preparation, transforms you from a passive potential victim into an active participant in your own safety and protection. 2 feet of snow sits on the ground across a vast region. Next week, temperatures rise and that snow becomes water that has to go somewhere. You now understand why that's potentially dangerous. You understand the 3 major threats. You understand what experts are forecasting, and you understand what you can do about it. The storm may be over, but staying informed and prepared keeps you safe through whatever comes next. If this information has been valuable, help others by sharing this video. Click the like button so more people see it. Subscribe to stay updated as the situation develops through next week. And drop a comment below telling where you're watching from and whether you've started preparing. Your experience and insights can help others who are facing the same situation. We're all in this together, and shared knowledge makes everyone safer. Stay safe out there, stay informed, and take care of yourselves and your neighbours.